Hello, in this video we want to find length DC in the diagram. So that is the length right here. And what I'm going to do to help my work is I'm just going to give that I'm going to call it X. So what I see is that X is part of triangle ACD, which is not a right angle triangle, meaning I can't apply my primary trig ratios. But what I do have is I have two right angle triangles. I have triangles ABC and I have triangle ABD. And if I can find length BD and length BC, I can then find the difference of them, which would be length CD. So with this question, step 1, I'm going to find length BC. So if we talk about length BC, we're going to use this angle here. And so BC is going to be the opposite relative to the angle 35 degrees. And we're given the adjacent. So if I have the opposite and the adjacent, I use tan. So therefore tan of 35 degrees is going to be length BC divided by 10. So therefore length BC is equal to 10 tan 35 degrees. Now at this point, I could, if I want, work out BC as a decimal, but I'm not going to do that. I'm going to keep it in that form because that way there's no approximation of the value. So now I'm going to do step 2. I'm going to find length DB. So in this case, we're going to use the angle here, which would be 10 plus 35, which is 45. And just a little point here, a little trick. What I notice right away is that if this is a 45-degree triangle and the length AB is 10, that means the length DB should be 10. Since triangle ABD is a 45, 45, 90, that means AB is equal to BD, and which is therefore they're both equal to 10 units. But if I didn't see that, what I would then do is I would use my primary trig ratios. So we see that DB is going to be what we're looking for, so that's the opposite, and then we have 10. So therefore we have the opposite and the adjacent. Tan of 45 degrees is going to be the opposite, which is DB. Align with that, divided by 10, and therefore DB is equal to 10 tan 45 degrees. And now I'm going to leave it in that form because that's as exact as possible. Again, it does work out really nicely, but in this case I might not know. So then step 3 is we're going to find DC. And DC is going to be DB minus BC. So therefore DC is equal to DB, which is 10 tan 45 degrees. Scroll over a little. Minus BC is 10 tan 35 degrees. And now I'm going to type this in my calculator one step. So I'm going to get an approximate value here. So I have 10 tan 45 degrees minus 10 tan 35 degrees. I made a mistake here somewhere, it looks like. Oh, I forgot a times. Let's try that again. 10 times tan of, oh, let's try that once more. 10 times tan of 45 minus 10 times tan of 35 degrees. And we hit equal, and we get approximately the value of 3 units. And we're done. So Again, not a particularly hard problem as long as we break it up and we look for our right angle triangles. But one little point that I think is really nice to use here is the idea that you notice this 45, 45, 90. Remember, we always want to be looking for 45, 45, 90 triangles as well as 30, 60, 90 triangles.